Okay, so hello everyone. This is Red. Today I'm going to give a presentation on some motivations of learning EVM. So it's gonna be pretty beginner friendly, like simple and easy, 30 to 45 minutes. And then after that, we can ask questions for 15 minutes to make the whole session an hour. Okay. So for a quick who am I? I'm a Web3 security researcher. I'm doing the security engineering intern at SigmaPrime. I play CTF is the DeFi Hack Labs community. I'm from a pure math cryptography binary exploitation background, and here's my Twitter. So I'm happy to connect with everyone. I think I need to share the link right with the audience. Yeah, I need to share the link. Where's the comments section? Oh, I see. Wow. Okay. So, what's the motivation behind learning EVM? First, obviously, when I learned the EVM, I use that to play CTF. After that, actually, you can doing EVM research and get a job. For example, you can do that at AlterSec and Zelig, right? I have friends who work there, like they play CTF really well. Their strength is in EVM, so it's possible to get a job, but it's pretty hard, like doing EVM alone, right? Third, you probably need EVM knowledge in your day job. For example, right now I'm auditing Rest, which is a Rust version of Go Ethereum. For auditing that, you have to understand how EVM works, right? Or you can just, because of you have curiosity, so you want to learn everything. The first step, I recommend checking out this collection by Mina. Mina is just a CTF player in my team. He collected this EVM puzzles, like everything that he had done in the past 2 years, I think, right? I also recommend solving these two challenges in onlyPwner. So this is a rather new platform by Opface, and I think these two challenges are pretty good. Right? You can do this just after the session. I share the slides with everyone, so you still have the links. How to learn EVM? I collected a list of resources you can follow. They are publicly online. These resources, I think you know. So the most notable things here is just this whole series by OpenZeppelin. This is an older one, probably like 5 years old right now. This is a list of articles by Knox. Right? These are pretty new. After that, you can learn how to read opcode, and eventually you have to read the Geth source code, so you have to learn Go first. Learn the Go language and then follow these Medium articles and then eventually read the EVM.Go source code. This is what I recommend everybody to do in your free time. Okay. So today, the main topic is I want to do a few case studies, basically the top two. The first one is I will talk about ABI encoding for the dynamic types. Also, this is a really sneaky bug, like the return in Solidity and return in Yul, they are different. Okay. Also, I have like a homework assignment. You can do it on your own. Is the pretty famous the OpenZeppelin ERC2771 Context plus the multicall library bug. Okay. Do we have questions so far? No. If no question, I'm going to do the technical part. No way. My English is pretty rusty. Okay. So if no question, we are going to do the technical part. So the first case study, actually, I have done this last year on Twitter, right? You can check my tweet, but I have some new thoughts to add into that. Basically, think of this, right? When you calling an external contract, you have to prepare your call data. If you are just calling a normal function, you can just call the name, right? But if you want to do like a low-level call, you have to do the ABI.encode family. For example, the most commonly used, I think, it is encode with signature. Like you do that in a low-level call, then you prepare the function selector and fill in the parameters, right? But I don't think everyone knows like what's happening behind that. So like under the hood, ABI encoding has a specification. For example, you can think of this dynamic type as just string. For example, hello world. It is a dynamic type. Is the ABI encoding of that is breaking down into three parts. The first part is the offset, length, and the actual data. It's okay if you don't understand because we are going into Remix IDE very soon. I will show you an example, okay? But the simple way is you can use this cast tool in Foundry Toolkit. I will show you in terminal. For example, you can do this. And the call data of this function takes three parameters. The first and third are dynamic types. They are strings. And the second is just a static type. It's U256, right? And I'm making it just like simple, like hello and 1337 and world. If this doesn't make sense to you, it's okay. I'm just showcasing like you can use the tool to get like quick call data, so you can analyze manually, right? We are going into Remix right now.
Brett, maybe can you show the terminal again?
Show terminal again.
Maybe for the youngsters out there, can you explain for us a little bit about how the parameters convert into these numbers, into these X codes?
Yes, I will, because I will do that in the contract.
Awesome.
Yeah. It's right here. It's the same thing, you see? So I'm just saying you can get call data this way. Yeah, I'm just showcasing this tool. The actual analysis is here. So in Remix, I wrote a simple test contract. There are 5 functions. The first is just ABI.encode pack, encode with signature, with selector, and encode call. So let's take a look at the first one. This one is the most standard ABI.encode that follows the specification defined in the Solidity doc, right? So I am encoding 3 parameters here. You can just think of these are the same, right? This is the same. So first parameter, dynamic type, static type, dynamic type. I'm just making things up so it feels more interesting, because if you do like all dynamic type or all static type, it's easier to understand. But yeah, I'm just making like a complex situation. Let's deploy the contract here. Control S, compile it, deploy. And not this one. We are deploying test ABI. So contract is deployed. Let's call encode and see what we got here. So I actually already analyzed the call data, but I will do that one more time to show you how I manually parsed it. Okay. So I just copy it here, delete 0x. First thing you notice, probably I will say here is the first 32 bytes. So I just press enter here, press enter here, because they are all like 32 bytes, right? So I just keep doing that, same thing. So that's how I got this data. I put in the comments there. Okay. So let's look at the call data. The first 32 byte slot, and it is the offset of hello. You can think of this is like a stub. This in the slides. I think of this as a stub. So what is a stub? I don't know if you guys learned the like dynamic linking in C language. There is a concept of like function stub. Basically, just in dynamic linking, the function definition will only be copied from libc when the function gets executed. So before that, the function stub is just like a name. So inside that is empty. It is the same story here. So this offset is telling us there is some dynamic type, like at location 0x60, which is here, I believe. Okay, so this is like you can think of it like a placeholder probably. So it's telling me, okay, so the first parameter is at location 0x60. Second parameter is 539, but in hex, that's the same as this number. Okay, so the third parameter is offset of world maps. So this part is like a placeholder, the actual data of the static type, and placeholder again. Do we understand this part? You can ask question now.
We're talking about the pointers and the data itself, right?
Yeah, it is called offset in half tutorial, so I'm calling it offset, but in some other literature, it is called pointer. They are the same.
So basically where the data starts and where the next part of the data starts.
You can think it like as a placeholder. So there is nothing here, but it's pointing somewhere in the end. Like this pointer points to this data, this pointer pointing to here. Yeah. I think when I added the space, it's pretty easy to see, right? Pointer pointing to the length of the first string, which is 5 because we have 5 characters here. The actual data is padded on the right. The actual content of the ASCII code is here. You can just use an online tool to translate. This is hello. This is world. And this is the length of hello. This is the length of world, both 5. This pointer, the first pointer pointing to location 0x60 here. The second pointer pointing to location 0x80, which is here. And the actual data is this part. String is the string consists of 2 parts, length and data. The pointer is like a placeholder. Do we understand this part? You can ask question. Okay. You all got it. Okay, nice. So let's move on to encode pack. This one is pretty easy to understand. You just pack everything together. Right? You see the data is this part, and then This is hello. This part is 1337 in hex, and this part is world. Yeah, this is pretty easy to understand. So when you are talking to an external contract, you must be using API.encode because this is the definition. Okay? If you send like a chunk of data to another contract, it's not going to understand it because this is nonsense. Okay. There are 3 other methods, but they are just like wrappers around API.encode. You can see this called it encode with signature. This one. You just append the function selector on the top. Right? The rest of the data, they are the same. They are the same as API.encode. Same data. Just one more function selector on the top, so the other contract knows like which function you're calling. Okay. Encode with selector, same thing. Just the semantics, like the syntax is different. Same story. Encode call, same story. Different. No, I mean different syntax. Okay. So the confusion is just some people think a string only has like a 2-part encoding, only length and data, because this is what they see in the actual memory. So if you are inspecting the running EVM in the memory, it is only 2-part. But when you see like 3-part encoding, that's the API encoding specification. So that's commonly the Calldata. So for like easier memorization, I will say just memorize it as 2 parts in memory and 3 parts in Calldata, because Calldata needs extra like the offset / pointer definition here. Okay. So that's the everything for the first case study. Do we understand this? Any questions? Yeah, so the confusing part is just like some documentation says 2-part and some says 3 parts. For example, like in Solidity doc, there's one section saying string has 2 parts, but that means in memory, right? In half tutorial, you see string is 3 parts. That's the API encoding. So they are different. Okay. Okay, so we finish with this one. If you want to try to debug on your own, you can follow this link, right? And read the Solidity doc. You can read half tutorial. And also I post the testapi.so in this GitHub gist. You can follow. Okay. Okay, if no question, let's move on to the second one. So this is slightly more advanced topic. Basically, I discovered this during a Securium race. I think it's race 19 probably. So the main idea of this one is you have a return statement in Solidity. You have a return in Yul, and they are different. So the main difference is Solidity return is actually not like is not the end of the function call, right? So for Yul, if you trigger that return, it's gonna terminate immediately. But Solidity, after seeing the return, it is still going to execute everything beyond that. For example, like a modifier. Yeah, I will show you the code. I have this test contract here. Let's read the code a little bit. So in this setting, non-reentrant is a reentrancy lock. So there is a state variable status defined to be defaults to 1. Okay? First, it checks if this is not 2, so pass. And then it sets the state variable to 2. Do the actual function call here. And then reset everything back to normal. The normal is this 1 default. Okay. And there are 2 functions. The first one is we do a normal return call in Solidity. The second one is a return Yul, because this is assembly block. Okay. So what's this line? This line is I put 0x42 into memory location 0x00, which is obviously this is not safe because the first 80 bytes are reserved by memory, but this is just like a simple demonstration, so it doesn't matter. Okay, so I put this number to the top of the memory, and then I return that location, which consists of this value. So they are equivalent. They are like semantically equivalent, but the effect are different. So I'm calling this as the Yul return, and this is the Solidity return. Okay, let's deploy the contract and see what happens here. First, we double check that status is correct. It is correct because it's not enter. We are not calling anything. Okay. Right now it is 1. Correct. Okay, so first we call Solidity return. And it is still 1. Okay. So let's see what's going on inside the call. Let's click this debug. So go into the debugger. Let's trace down this execution. So he's doing some setup here. Okay, so this part is pretty interesting. Just look, okay? Right now it's in the modifier. I'm doing like as store to modify this state variable, right? This is normal. Everything looks good. Okay, so we are going into the function. Look this line. Are we noticing something interesting actually? Like this part is the highlight is only on the number, it's not on return, because it's not calling return right now. You see, there is no return opcode. So although we executed the return statement, actually return opcode is not here. It's not actually calling the return opcode. See, this is pretty interesting. Why? Because look, so when we are here, right? We are actually on this step. We are in this underscore. So there is code behind that, and Solidity is very smart. The compiler knows there is 1 line of code after that, so it's not calling return. It's actually what it does is push 40. This means 0x40. It is pushing 0x40 onto the stack. You see, push 1 or 0.
Push it to the stack and then return it. That should be the case, right? Push it to the stack and then after the execution, return it.
Yes, it is, but see what happens now. You see, it's actually going back to this line.
I see.
It's not terminating. Yeah. So actually, the Solidity only stores this number onto the stack for a future return, because eventually it will return. But in the very end, so it's storing the 0x40 onto the stack for future use. And right now we are executing the last line. This line we unlock the the reentrancy lock, right? Here we are unlocking it. After that, it goes back to this function to return it. Blah, 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 blah. And eventually, in the end, you are going to see the return. So the control flow is we execute these two lines first, and then we go to this function because this underscore, we store 0x40 onto the stack, and then we go back to the modifier to unlock the reentrancy call, and then go back to the function to finish everything. This is Solidity return. Okay, so this is what we want, because we are doing this modifier thing here. By writing this code, semantically, we mean every line of the code will be executed. That's what the developer, the developer wants, right? So everything good here, everything nice. And let's look at the ugly case, which is Yul Return. Look at this, okay? I'm calling test assembly return. This one. I call it, it works. However, you see?
What?
It's changed. That is changed. This is really bad because right now status is 2. Why is 2? Because it says entered. Even though like the execution of this function finished, we are completely out of this function. The reentrancy lock is not unlocked, which means your contract is locked forever. You see?
But I do have a question.
Forever.
I have a question.
Yes.
Go back. Can you go down a little bit? So you're telling me that you're storing the entered status on 0x52? That's the storage address?
Your voice is kind of broken on my side. Can you just type on the...
Sorry, yeah, 1 second.
Okay. Yeah.
Better now? Is it better now, bro?
Oh, yeah, it's better now.
Thank you. So sorry, it's I have problems with the mic. So the question is, where in the memory or in the storage are you storing the status? On 0x52?
This part is in storage, and this is memory only.
Yeah, but my question is go down. So you're telling me that 0x20 is holding the status data?
Oh, you are talking about this. Okay, so this means you are storing this number to this location. So offset that value. You are storing the value into this offset. So right now, the memory location.
I mean, yeah, just keep on. Sorry, I had problems with the mic. Just keep on explaining.
Okay. Where am I? Okay. Oh, I just demonstrate that. We are expecting that both function, after calling both function, status should be 1 because we already leave that context. But in this case, the reentrancy lock is never unlocked. So this is pretty bad. That which means this line of code is never triggered by this function. It is never triggered. So the control flow ends here. Okay.
Interesting.
So if you don't believe it, I can show you in the debugger. This is the call. Let's go into the debugger. I think this is test assembly. Yes. So executing this line, okay? Require, updating the state variable, lock it. Lock it. Go into the assembly. This is just 1-to-1, you see? I push 40, I push 42 onto the stack. I push 42 onto the stack is here. I do add store. Now memory should be updated. Memory has 42. I push 20 onto the stack. Stack changed. And then return. Boom. It finished.
Basically, the modifier is being ignored by the assembly.
Basically, this line is never executed because this is just like a leave.
Oh, okay.
It's return.
I understand.
So just remember, in Solidity, everything looks good. But in Yul, if you do this return, don't expect anything
to happen after, right?
So even though you write code after it, the function is not going to trigger it. So just beware. In this case, it is pretty bad because it is like a DOS to your contract. After calling this, the lock is never got unlocked. So any call after that, reverse. Your contract at DOS. Okay, so do we understand this part?
Yes.
Let me see the comment.
So basically, from what I understood, whenever you're dealing with when you call return, you actually call in the return of code, and nothing will happen after that.
Yeah, basically like that. Yes. Yeah. So Solidity has the like the smart part, but in Yul is just like a brutal returns. Okay. I think people understand. Yes. Yeah. This is the return data size. Yes. This is the return data, the actual data location, which is memory 00. Okay. Yeah, I think people understand it.
Yeah, pretty sure.
Yeah, this is pretty interesting.
Really?
This one is interesting. Yeah, I think the first one is just like a warm-up, but the second bug, I don't think many people understand this. So same, if you want to try on your own, just follow my step. You copy my code. I share my code here. You copy my code and go into there. Just like click something and then hit debug and then just trace the opcode one by one. Okay. Let's move on to the third one. So we are 40 minutes in. I'm not going to be very thorough on this one, but it is a homework assignment for you anyway. So basically everything starts here. OpenZep in December 7 last year disclosed a bug happened in their library where you have to combine, like your contract have to inherit two contracts. The first one is 2771. The second one is multicall. You have to have both contracts inherited. So ERC2771 is a metadata transaction, which means a metadata transaction just, for example, like a user doesn't hold ETH or any native token on the certain chain, but they want to send a transaction. However, because they don't have the native token, they can't pay gas, right? So meta transaction means you make a off-chain agreement with some third party, and then they pay you the gas. So, for example, you want to withdraw like $20, right? The third party probably charge you like 50 cents for gas, and then they give you 19.5 token, and then the lost part is just like used as fee, so they are paying the gas, right? So if you look at the diagram, basically this user doesn't have the native token, and then this trusted forwarder is paying the gas. This is like a third-party company. They are doing this as a service. Okay. So this one is the target contract. And in the case of attacker, just user is attacker. The victim contract is this. Okay. So this one is actually pretty easy to understand from the high level, but if you want to figure out the detail, it's gonna take I would say more than 2 hours to figure out the details. Basically, the idea is you are calling the trusted forwarder, but the victim contract doesn't know who you are, so they only know this trusted forwarder, and this guy knows who is the actual message sender, right? For example, if I want to know who is the message sender, it is using this function inside the OpenZeppelin library. So the definition of this one is just it's gonna look for the last 20 bytes of your call data. So this is a pretty naive implementation, right? So it's only looking at the last 20 bytes of the call data. So somehow you can just manipulate that, right? How to manipulate the call data part is you execute in multi-call to the trusted forwarder. So inside multi-call, it is like a delegate call. So although the name is multi-call, but you are just using that to do one call. So we are just utilizing the delegate call part. So we do a delegate call here. So the forwarder calls multi-call. This one is trusted, so they can communicate. And then you are just manipulating the call data to add the trusted third party, add their address to the end of the call data. So the message message sender function in the victim contract is going to parse that part and think this one is legit. I think it's probably pretty hard to understand.
Yeah, I mean, we can have an idea,
didn't read this,
but it's a little bit hard to understand.
So I just want to make it as a homework assignment so you can
very nice
learn on your own, because it's pretty hard to explain, you know. So the idea is just you have to have ERC2771. Also, you have to have multi-call. You have these two functionalities combined to make this call data manipulation attack, I will call it. Okay. And so I suggest you follow this one. Follow the top one that causes like 85 ethers lost. It gets you into a Falcon IDE, and you can just play with it.
Falcon is really cool.
You can do that in the team. Yeah, I'm not going to walk this through with you.
No problem, bro.
Do it on your own. Okay. Yeah, it's gonna take more than an hour to explain everything. This one is slightly more complex. Yeah, the idea I just said it, but I don't think anyone understands. Some help that you can use. Actually, 30K had this article. This article is pretty nice. It is actually pretty correct. This one is the best article on this hack I found on the internet. And if you are doing this on your own, make sure you go into OpenZapling library, but don't look at the latest code because they already fixed everything. You just click on the commit and then go back to probably like half a year ago. That version was 4.8 or something. Like you can look at the old code, right? I have this Calldata analysis here if you want to check it. Also, last week, I think it was last week weekend, OpenZapling hosted Ethernet CTF, and there was a challenge based on this hack. You can try that on your own. They released the infrastructure, also the challenge code, so you can deploy everything locally and solve it on your own. Okay, thank you. That's everything for today.
Awesome.
Any question?
Awesome talk, man. Congratulations on the talk. Very nice. You guys have any questions?
It's really hard to live event.
Nah, you did super great, bro. Let me see if people have questions here. Most likely, you know, they
can ask me like any question. Not necessarily on the technical part. You can ask me like general questions.
Awesome. I want to know
too personal.
Okay, I want to know a little bit about the experience of being an intern on a auditing firm. What your day-to-day looks like. How much you've been learning from that.
Yeah, I can talk about it. So basically, when I got into the internship, they almost finished with the Tycho audit. Tycho right now is running a contest on Code Arena. That's the same one. I read their report and then I studied ZK rollup that things for like 2 weeks, and then after that I got into the Ret audit. I just mentioned that. So it is like a Rust version of Go Ethereum written by Paradigm. That one is pretty hard, actually. It is pretty hard. First, it's written in Rust. I didn't have experience on Rust. I just learned the language from zero, and then I have to learn Gas first, and because that's pretty hard, you know. You have to understand Gas in order to audit Ret. So I learned Go.
Awesome.
Go language, and then I study Gas, and then I go back to study Rust once more, and then I come back to Ret, but it's still pretty challenging. I still have like 2 more weeks here. I have to find some bugs to prove myself. But I don't think the internship is hard for everyone, because I am doing this audit because I think it is because like my supervisor is the manager of this project. So if you got into SigmaPrime, probably you will get some easier experience if your supervisor is handling like some normal smart contracting. You know, it is always easier to audit Solidity, I would say.
Can you talk a little bit?
It is.
Can you talk a little bit about, not, you don't need to disclose the details of, you know, but what is the interview process? Like you have one interview with the manager, then you have to do a technical test.
Yeah, I can talk about it. Interview, it is just, the first round was a technical interview with 2 senior auditors, and then the second interview is with the co-founder.
So the technical challenge were Solidity based?
Technical challenge, Yeah, they will ask you Solidity, but there is a personalized part. So basically, you have to introduce yourself, introduce your background. If the interviewer knows some like challenges other than Solidity, and you mention that you know it, they will find out if you really know it.
Awesome.
Yeah. Let me check out the comment area. Follow the EVM course on ciphering abstract. EVM course, I think, is the Foundry plus Solidity course, right?
Must be.
Learn anything. I recommend you to learn DeFi in general. For example, Uniswap, Compound, Optimism, right? Those famous names. You have to know the DeFi primitives. I I actually think the Solidity part is less important. DeFi is important.
There's any trick to learning DeFi? Any path you followed? They gave you some sort of advice on how to learn that?
Basically, you have to read documentation. You have to read the source code. After that, you can just find like a similar context on Code Arena. For example, I would say learn Compound first, and then go to Code Arena and search for Venice Prime.
Really nice.
It's Venice and Venice Prime. So this project is pretty similar to Compound, and it was audited last year, and you can read the report. Or if you have time, you can just like shadow audit everything, right?
How busy have you been recently? You know, I mean, how auditing is influencing your life? I mean, are you feeling more stressed? Are you being able to handle
I'm pretty busy. I'm depressed.
No, bro, you're so good. Don't be depressed.
You don't know, man.
We here, man. Don't be depressed. Don't be depressed. We here, okay?
Yeah, I'm joking. Yeah, just because I have to read Roscoe. Roscoe is pretty hard to read.
Really true. Amazing, brother. I mean, very nice presentation. Do you have any closing thoughts? Any message you want to leave people that will hear this in the future?
I actually have one, but yeah. Anyway, I will just mention. So, DK Hack, that community just reached out to me. They want me to like host a Moon Math DK manual study group on their Discord.
Nice.
So it's probably happening in April, but on their side they are still discussing. Like they want to invite the author team, also the CEO of this authority. They want to invite everybody there, right? So once we figure out the how it's gonna run, like when is the opening date, I will share link here.
Awesome. I'll be super excited. Awesome. I'll make sure everybody goes there.
Yes. So no, you should only do that if you really want to learn ZK.
And I guess we have one last question from Switch Jiggy. Yes. How long you've been auditing when you got your first payout?
My first payout, I think about half year to make my significant payout.
Awesome.
Yeah, before that it's just like bullshit, $20, $50.
But that's yeah. That's the standard. I mean, that's the standard. Most guys, they'll get shitty payments until 8 months, and then start to have mid payments, and after a year they start having like 1,000, 4,000, 5,000, and then then it just go up.
Yeah, I think the key is just you have to find out like which subfield that you are good at. For example, if you want to do Rust, if you want to do ZK, or even Rust plus ZK is what I'm doing. you have to find like a niche that you are good at, that which can distinguish you from other people.
Amazing, bro.
And so just focus on that. For example, you can do L2, you can focus on ZK rollup, and focus on ZK EVM, right? Something like that.
Awesome. I think this is it. Thank you so much for coming.
Thank you.
It's a pleasure talking to you every time. You're always super available and a super cool and smart dude. I hope we bring more people like you here. Feel free to come anytime you want. And this is it, everyone. Thank you guys for showing up.
Yeah, thank you, everyone.
See ya.